Bismillah wassalatu wassalamu ala rasulillah amma ba'd. Hello everyone, I am Mohammed Alhibshi, biomedical engineering student at King Abdulaziz University. Today I will present BMode measurement in ultrasound imaging. BMode, one of the most important and basic modes in the ultrasound to produce 2D or 3D images. So it's important to take into the consideration the way of obtaining or calculating the BMode measurements. And also it is important to take into the consideration the BMode measurement errors. Caliber systems. The caliber systems are used to make the measurement from simple measurements such as linear distances to a complex measurements such as volumes. Scanners are using these measurements to perform the needed calculation for BMode. Circumference and area measurement, or nonlinear distance measurement. The measurement of irregular circumference, which is the distance of perimeter of a structure, could be performed by tracing. Using the trackball, the outline of the structure can be traced when the caliber is set on one end point in the structure. Another thing that is the system provides a guided line plot during the movement of the trackball. Then the system can calculate the distances between the outline points of the structure. Here in the picture we can see the tracing measurement of an application of obstruct. Another thing that is there is an option for true elliptical structure measurements. The caliber is set on the end points of the long or short axis of the ellipse, while the other can be adjusted by the trackball. Also, the size and the position of the ellipse can be adjusted. As we can see here in the picture, this is an application of obstructs for true ellipse measurements. And usually these measurement methods used in obstructs application. Now with the volume measurements. To make a measurement of a volume using two-dimensional images, the two images need to be acquired perpendicular to each other. That means 3 diameter orthogonal to each other and a constant K are required for the volume measurements as shown in the right figure here. To calculate the volume, the diameters are multiplied together and then multiplied by the constant K to make the appropriate shape. This shape is approximately sphere by using a K value of 0.52. Automatic measurement. Automation of the measurement using image processing has been developed to do the measurements using indirect process that performs the same measurement process by the human. The machine learning assists in plan recognition of the image and automatic measurements, and advanced algorithms are saving time and provide results as observed by expert observer. The automatic measurement can be performed simple measurements such as measuring the distances between adjacent surfaces to more complex measurements such as volume measurement. The automatic measurement system are used intensively to perform the measurement of cardiology and obstetrics, while there are some effort to perform the measurement for fetal, but still for commercial uses and availability is limited. Here in these two pictures we can see an application of automatic measurement. In picture A we see automatic recognition of central midline in the correct fetal head imaging plan, and in picture B we can see automated measurement of fetal head circumference. Now let's move to BMode measurement errors. The measurements could be sometimes different from a true value when an observed value differs from the true value that's called observation error. In measurement, there are two types of errors. systematic and random errors. Both systematic and random error affect the accuracy of the measurement, and the random error only can affect the reproducibility. Random errors. Naturally, the random errors is accidental to the observer, either during the observation process directly or in the systems that lack of precision. When there is an deviation from the true value, the obtained measurement is not correct. So, when several measurements above and below the true value are obtained, then taking the average of these values will make the result near to the true value. Coefficient of variation is used to measure the random error, which is the percentage of the standard deviation to the mean of series of measurements. As we can see here in the right table, which clarify the mean and the CO or COV or coefficient of variation of 10 values that taken by 2 observers. And the true value of the measurement they do is clarified below the table. The systematic error. The systematic error possibility comes from both the observer and the instrument. This error can't be revealed by repeating the measurement like in the random errors. Revealing this type of error is by comparing the measurement taken by the observer or by a proper test object measurement. Here in the table on the right, since the true value is 314 millimeter, the systematic error is 6 millimeter for both observers. Another thing that is there are some inevitable systematic error due to the imaging process, but can be minimized by selecting suitable scanner and method. So this is the end of the presentation. I hope you enjoy it and thank you for your time.